All right, good morning, everyone, or hello, everyone. It is Dr. Ihrig. We're going to be talking about exponential functions again, but we're going to be talking about how to write the equation of an exponential function once we have a table. So like we're given a table information, we've plotted the table in, we know that it is an exponential function, but how do we determine the initial value? How do we determine the formula that goes with it? So I really like this graphic. I have no idea where I got it from, but I feel like it's a really great example of what to do. So first, you're determining, is it exponential? Now, there's two ways to determine if it's exponential. If you can't tell by looking at it, go over to your Desmos calculator, click the plus sign table, and then whatever values they give you, just type those babies in. So now that I've done this, remember that in order to connect these dots, I'm going to hold this green button down and turn on lines, and then I'll scroll out, and we can see by scrolling out that that is indeed an exponential function. It's like whoosh. So now that we know, yes, it's exponential, we're going to determine the starting point. Now the starting point is going to be, in these cases, when x equals 1. So our initial value from this table is 4. If we go down to this example, here's x equals 1, so our initial value is going to be 5. The next thing it wants us to do is come up with a common ratio. Now, when we were doing linear functions, you knew that you kept adding, like you kept adding 5 halves, or you kept adding or subtracting -2 or whatever. Here, it's a multiplier. And so the way that you determine the multiplier is you want to make sure that each one of these, it's almost like you're doing a rate of change. If we do this number divided by this number, you'll get a value. And then you want to double check. This number divided by this number gives you a value. This number divided by this number, same number. So now we know what our rate is. If I go over here for the problem that I'm modeling down here, that would be saying 10 divided by 5. So I'm just going to type here 10 divided by 5 and I get 2. Then I'll do 20 divided by 10 and see what I get. 20 divided by 10 and I get 2. And I could keep going, so that means my common ratio is 2. And my multiplier is every time I just keep going up by 2, up by 2, up by 2, up by 2. So now what we're going to do is once we have here, we're going to just write the function. Now remember, on the formula sheet, they give you this wonderful thing where A is the initial value and B is the multiplier or the common ratio. So this is the formula sheet formula. So we just have y equals, but I'm going to write f of x because we want to get used to writing functions. The initial value, which is 5, my common ratio, which is 2, and then we always have x on the top. Let's look at the next one. Here is 1, so my initial value is 800. Then we have to determine the multiplier. So we're going to do 400 divided by 800. It is totally fine that the bigger number is on the bottom, because that just means we get a decimal. And let's do it again. 200 divided by 400. Same decimal. 100 divided by 200. Same decimal. So my common ratio will be 0.5. So how do I write my function? Let's write f of x. So we get used to function notation. My initial value is 800. My common ratio is 0.5. And then I write x. It looks complicated, but it's not. I know you got this. All right, see you soon. Bye.